So here we have our first problem on DC-DC converters, which are also known as choppers. Okay, so the first problem here, we are going to look at a biconverter. Okay, a biconverter is a chopper that steps down the DC voltage. Okay, so the output voltage is always smaller as compared to the input voltage for the biconverter. Okay, so we are given the parameters here. Okay, we are given the source voltage, which is the input voltage, which is 24 volts. We are given the duty cycle, and of course, the duty cycle is simply the ratio between the on period of the waveform to the total period of the waveform. Okay, so that is it. That is it. The duty cycle. Okay, so we are also given the inductors. Okay, the inductors given is microhenry. Microhenry, and we're given the capacitance as well as the resistance, and also given the switching frequency, which is 100 kilohertz. Okay, so let me just draw the circuit for the back converter. Okay, so we have the source voltage. Sorry. Okay, so we have the source side here, which is DC. Okay. We have the switch. Okay. So this switch is not the actual switch like the common switch, is actually the electronic switch like a transistor. Okay. And then we have a diode. We have an inductor, and we have a capacitor. So this is the circuit setup of a biconverter. And then this side here, we have the load. Okay. So what you're trying to do here is trying to step down this high voltage. Okay. So it might be remember the input is always high as compared to the output, and they want to get a smaller value of the output voltage of the inductance here, the capacitance here. So this capacitance, the job of this capacitance is to make sure that you maintain the constant voltage across the output here. Okay. And then we have the diode, and this is a switch. So as I said, this switch can be a transistor, a MOSFET transistor. Okay, MOSFET transistors are the ones that are commonly used. So you have a switch here. Okay, so this switch will be switched based on the frequency given. Okay, how fast to be switched on and off. So here we are told that okay, the switching frequency is 100 kilohertz. Okay, so meaning this transistor, okay, how many times it's been switched in a second? It's 100,000 times in a second. So it's switching this transistor here. So this switching here has got an effect, okay, to the output voltage here. How fast you switch it, it also determine how much voltage you are going to get on the output. Okay, so I'm not going to go into much details about the formulas and the calculations. I think I'll do that in the videos, of course. Okay, but in this problem, I just want to solve a problem. Okay, want to find the output voltage and also the maximum and the minimum current of the inductor. Okay, so here we just use a couple of formulas. So for the first question, the output voltage. So the output voltage for the back converter is given by the source voltage times the duty cycle. Okay, so as you can see, the duty cycle is always less than 1. Okay, so the duty cycle is always less than 1. So you can see that the output voltage will always be less than what? The input voltage. Okay, so the output voltage will be equal to the source voltage 12 volts. Is it right? Oh, sorry, it's 24 volts. Yeah, we have 24 volts here. Times the duty cycle, which is 0.65. Okay, so from this, we need to calculate the output voltage. Okay, let me just grab my calculator. Okay, so for my calculations here, I'm getting the output voltage to be equal to 15.6 volts. Okay. Oh, sorry. So I have 15.6 volts as my output voltage. So VO equal to 15.6 volts. Okay. And then part B, we need to find the maximum and minimum inductor current. Okay. So for the buck converter, so part B, the I mean is given by this formula. Okay, so the I mean is simply equal to the output voltage multiplied by 1 over resistance minus, sorry, not plus, minus 1 minus duty cycle over 2 times inductance, okay, times time period, okay, the switching period. Okay, so this, remember that period is simply 1 over frequency, so we can substitute that since we're given the frequency in a problem. So we have I mean is equal to VO 1 over R minus 1 minus duty cycle divided by 2L times F. Okay, so we substitute the values that are given. We are given the output voltage. Of course, we're just from calculating the output voltage, which is 15.6 volts. Okay, the resistance we're given, which is 10 ohms. The duty cycle is 0.65. The inductance we are given as 25 microhenry. So this 25 times 10 power negative 6. And then we are given the frequency, which is 100 kilohertz. 100 times 10 to the power 3. So if you calculate this, you find that the minimum current is simply equal to 0.468 amps. Okay, this is the minimum current of the inductor. Okay, so I'll explain this terminology in another video I'm going to make. Okay, and then C, which is of course not C. Also have to find the Imax. So my Imax is simply the same formula. The only thing you do is just change the sign here. Okay, so Imax simply VO. This formula is for buck converter. Don't use it for other choppers, please. Okay. So this is just for buck converter. It's only applicable to a buck converter. For other choppers, like boost converter or buck boost converter, you find that the formula will be different. Okay, the formula used to calculate the maximum minimum current will be different. Okay, so 1 over 10 plus 1 minus 0.65 divided by 2 times the inductance, 25 times 10 to the power negative 6 times 100 kilohertz. So Imax is equal to, so if you calculate this, you have 2.652 amps. Okay. And then lastly, we need to find the output ripple voltage. Okay. So, and that ripple voltage is actually dependent on the capacitor. Okay. The capacitor that you put here, as well as the inductance. Okay. So the formula that you need to use for this ripple voltage. So we need to find the output ripple voltage, of course. So this is part C. The formula is given by delta VO. So this is a ripple voltage is equal to the output voltage, okay, multiplied by 1 minus duty cycle divided by 8 LCF squared. So F is the frequency, or this one, you can also write it as a VO 1 minus D times T squared divided by 8 LC. You know that T is simply 1 over F. So either this formula, if you're given period, then you can use this. If you're given frequency, you can use the first option. Okay. So delta V is equal to the output voltage found 15.6 1 minus 0.65 or divide by, sorry. So this divide by 8 times the inductance. So inductance is 25 microhenry. Okay, times the capacitance, capacitance simply 15 microfarads. Okay, and then times the frequency, which is 100,000 squared. So don't forget to square this. So the ripple voltage is simply equal to 0.182 volts. Okay, so this is the end of the first question. The next question we're going to solve, in the next video, we're going to solve the boost, problem on boost converter. Okay, thank you so much for watching.